Alright, grade 10s, let's just quickly take a look at this work that you need to be doing today. I'm going to do a few examples, but first I'm going to explain one or two things. Okay, firstly, on my Cartesian plane where I have my x-axis and my y-axis, we have a positive side. You see here 1, 2, 3, x is positive there, and y is positive above this line here. You see all of this, y is positive. Okay, but in each quadrant we can then determine whether x is positive or y is positive. Remember, this is my first, this is the second, this is the third, and this is the fourth quadrant. Okay, we can determine in each one whether x is positive or y is positive. Quick and easy. Here x is positive, larger than 0, and y is positive, it's larger than 0. We can see that. Now in the second quadrant, what do we see? Let me just switch colors. You can see that x is actually negative, it's less than 0, but y is still positive. Okay, then in the third quadrant, x remains negative, y is actually also negative. And now here in the fourth quadrant, x becomes positive again, and y is still negative. Alright, so you need to know in each section, you can quickly determine it. You need to know whether x or y is positive. And remember, we have our friend r, which is always positive. Okay, next let's take a look here. If I take a look at square roots, I say x is equal to roots of 4. I actually have two possible answers. I say x is equal to 2 or x is equal to minus 2. Why do I say that? Well, this equation here is asking me what value of x can give me the root of 4. Okay, and how do we determine that? Well, if we take 2 squared, okay, then we'll get 4. Alright, and if we take minus 2 squared, then we'll also get 4. So both minus 2 and 2 are acceptable answers for my square root. Just remember how our square roots work. It's asking us which value squared will give me 4. So that's why I rewrite my answer actually as plus or minus 2, because it can be both. And you'll see how you choose whether it's positive or negative in the examples. So for this first example, they tell us if tan theta is equal to 5 over 12 and sine of theta is positive, determine by means of a diagram these two expressions here. Alright, this one and this one. We don't worry about that too much. We need to look at what they give us. Very important, these two statements here, by means of a diagram. So firstly, I'm going to write down that expression. Tan theta is equal to 5 over 12. What does that tell us? That gives us a lot of information actually. We see that tan is positive, okay, and that's useful to determine which quadrant we're in. And they also tell us that sine, and that's theta and theta, is also positive. Well, let's take a look at our cast diagram quickly. Alright, if I just quickly draw my diagram. Alright, and let's mark off. Where's tan positive? Well, tan is positive here and there in the first and third quadrant. And where is sine positive? In the first and the second quadrant. So we see that we are actually located in the very first quadrant. Okay, I'm just going to quickly hop to a new page where I can draw all of that now in the first quadrant. Let me just get a nice sketch here for you. So when they say with the help of a diagram, this is what they mean. You need to go and draw it in like this. So this is my triangle, my right angle triangle, and they give me the values. So we can see that it's in the first quadrant. Now, they also tell me that tan theta is equal to 5 over 12. But I know that tan is equal to y over x. So that tells me y is 5, okay, and it tells me that x is 12. So y is 5, x is 12. How can we calculate r? Well, we use our old friend Pythagoras. So I go say r squared is equal to x squared plus y squared. I substitute back, and remember my reasoning against Pythagoras. I substituted in, that's 25 plus excuse me, x is a 5, x is a 12, so it's 144 plus 25, which gives me 169. I take the square root of both sides, right? And what do I get? I see r is equal to plus or minus 13, but r is always positive, so I just say r is positive 13. So I can go substitute that in there. And when we have this diagram here on the left hand side, then we sort it. Okay, then we can answer their question. So they're asking, I'm going to rewrite it. They ask 13 cos theta. So the first question is 13 cos theta. Well, what is cos theta equal to? It's x over r. I just substitute that in. It's 13. What is x? X is a 12 and r is a 13, right? So my answer becomes 12. That's the first question answered. Just the second one left where they tell us cos squared plus sine squared. Okay? So I'm going to write it there. Cos squared theta plus sine squared theta. We go rewrite it in terms of x, y, and r. Cos is x over r all squared because of the square there. And sine is y over r all squared. I'm going to substitute in from our diagram above. What do they tell me right here? They tell me that x is 12 and y is 5. Okay. So let's substitute that in. X is 12, r is 13, square it all, plus y is 5, and r is 13 again. I square it. What do we end up having? And you don't have to show all these in-between steps. If you just show me this initial one, substitute, and then you're fine. What do we get? This is 144 over 169 plus 25 over 169, and that indeed gives us 1. That's your answer. Okay, I'm going to stop right there, and I'll do the next example in an additional video just to keep them a bit shorter.